The impact of commercially available microbial inoculants on Bermudagrass establishment aesthetics and function, published in Crop Forage and Turfgrass Management in 2022 by Bolton, Cabrera, Habteselassie, Poston, and Henry. Bermudagrass is one of the most widely used turfgrass species in the southeast region of the United States. Tolerance to drought and heat make Bermudagrass a popular choice for home lawns, athletic turf, and golf courses. Fertilizers are costly and may negatively influence the environment when misapplied at excessive rates or by improper techniques. Current turfgrass sustainability research has aimed to investigate alternatives to traditional nitrogen fertilizer applications in order to limit the negative environmental impacts. Biostimulants include an assortment of microbial and non-microbial products that are intended to enhance plant nutrition establishment and growth and stress tolerance. Previous research involving incorporation of microbial biostimulants in turfgrass management systems has been limited. Although microbial inoculants are more widely adopted for use in horticulture and agronomic crops, several challenges exist regarding their use and efficacy, with some being more specific to turfgrass systems. Most commercial products contain foreign microorganisms that have difficulty competing with native populations acclimated to regional environmental conditions. Therefore, the objective of our research was to compare Bermudagrass establishment in a controlled environment and to determine the quality and function of mature Bermudagrass stand in the field in response to commercially available microbial inoculants. So basically, the situation is turfgrass is used, sometimes it's fertilized. Microbial inoculants might be able to be used in place of fertilizer and maybe potentially reduce the environmental risk associated with some turfgrass management improper practices. This study included a field study that was conducted in Athens, Georgia at the Research Center. It also included a study that was conducted in Bogart, on a residential lawn in Bogart, Georgia. They were both on Tifway hybrid Bermudagrass. The one at the Research Center was 5-year-old Bermudagrass, and the one on the home lawn was 2-year-old Bermudagrass. They used labeled rates and carrier volumes of treatments, and I'll go over that when I get to the table. No fertilizer was applied to either site during the duration of each trial. They measured turf color, turf quality, NDVI. They measured it at 2, 6, and 8 weeks after application, and they measured it on a 1 to 9 scale, with 6 being the minimum acceptable. They also measured carbon flux as a measurement of basically photosynthesis. They also did a greenhouse study, which was at Georgia on Sahara 2 seeded Bermudagrass. They used 2 pots per trial per replication, and they used those pots from destructive sampling to measure the roots and the shoots from the influence of these treatments on the shoots and roots after seeding. And in that case, the stock solution of each microbial inoculant was prepared in distilled water to deliver the same 8 treatments. Now, here's the treatments. They used a non-treated check. They used a product or a microbial inoculant called Klebsiella varicola. And they applied it once, or they applied it once, and then 4 weeks later they applied it again. They used Aspergillium brasiliensis once, or they did it once, and then 4 weeks later they applied it again. Or they applied a different formulation of the Klebsiella varicola, and then they applied that once, or they applied it again 4 weeks later. And then they used the last microbial inoculant was a microbial inoculant called Gluconactobacter diazotrophicus. And then they did that once, or they applied it again 4 weeks later. And essentially, the results are 2 weeks, 6 weeks, or 8 weeks after application in the field at the Research Center in Athens, Georgia. They found nothing differed from the non-treated turfgrass. So there were some differences among the microbial inoculants, but nothing resulted in greater NDVI, turf color, or turf quality at 2 weeks, 6 weeks, or 8 weeks after application in Athens, Georgia in the field. When they looked at carbon dioxide flux, there was no difference at 4 weeks in the field, but there was a little bit of a difference here from the Klebsiella plus Klebsiella applied 4 weeks later, and from the Azospirillum applied once compared to non-treated. It went from 12.5 in the non-treated to about 15, a little greater than 15 micromoles per meter square per second at 8 weeks, but nothing at 4 weeks. When you go to the Bogart Lawn location, the same situation occurs where there was no difference at 2 weeks, 6 weeks, or 8 weeks. There's no treatment that resulted in a greater NDVI, turf color, or turf quality compared to non-treated turf grass. There was one instance here where you see the non-treated turf grass was 6.8, and the application of Azospirillum resulted in a turf color of 6.3, a reduction of a half a point, and it was statistical. So there was actually a little blip where there was a reduction following the applications of one microbial inoculant. But there was no location, no time when the microbial inoculants resulted in greater NDVI, color, or quality on the home lawn. When you go to carbon dioxide flux, there was, there was no difference at 4 weeks or at 8 weeks in carbon flux from non-treated turf grass. So they didn't do anything in turf color or quality or NDVI, and the microbial inoculants did not result in any greater photosynthesis. When you look at the greenhouse study, when you're looking at roots and shoots, there was no microbial inoculant that resulted in greater roots or shoots in the experimental run 1 at 3 weeks after seeding or at 6 weeks after seeding. No differences. And then from the non-treated turf grass. And then in experimental run 2, there were no differences at all between non-treated turf grass or any turf grass treated with microbial inoculants on roots and shoots 6 weeks or at 3 weeks after seeding. Okay. The short and skinny of it is microbial inoculant applications did not consistently increase hybrid Bermudagrass NDVI, turf color, turf quality, carbon flux in the field, or common Bermudagrass root and shoot biomass in the greenhouse. Nothing differed. And the conclusions, they basically postulate saying endemic microbial populations that have adapted to survive and proliferate in turfgrass environments may outcompete non-endemic microorganisms recently introduced into the system, meaning they didn't see a response. The likelihood is that the existing population of microbes in the soil were able to outcompete any foreign microbes that were added as a microbial inoculant from the treatments. If you want the long form version of this video, I'll post a link to it up here. Thank you.